Now see the question number 27. Question is that the minimum force parallel to the plane required to move a body of mass m with uniform velocity up an inclined plane of angle theta with the angle of repose lambda is. The first option is mg sin theta minus lambda by sin lambda, and the second option is mg sin theta plus lambda by sin lambda. Third option is mg sin theta minus lambda by cos lambda, and the fourth option is mg sin theta plus lambda by cos lambda. Now see how to solve this problem. First of all, I would like to explain the question clearly. So question is this: this is the inclined plane, angle of inclination your theta, and angle of repose is given your lambda. What is the meaning of that? Angle of repose give you the coefficient of friction. So as we know, mu is equal to your 10 lambda, where lambda is the angle of repose. So from this, given is that this is the particle or a body, and if this particle has to move in the upward direction with uniform velocity, if it is going upward v, which is uniform, it means the whatever the force is acting on the body, that should be balanced. That they are asking the minimum force parallel to the plane required. See, if we are making a video of this, forces one is your mg, another your normal, and if it is moving your upward, so definitely the friction force will act in the downward direction. So that force F, if I am resolving all forces, mg sin theta, if this angle theta, this is theta, when we are resolving the weight mg, so this will be your mg cos theta, and the another component of mg in that direction, that your mg sin theta. But as per the question here, our velocity should be uniform. It means the forces which are dragging the particle in the backward direction, those forces has to be nullified. So we should require a force external opposite to that. So for uniform velocity, F external must be equal to friction force plus mg sin theta, and friction force is your nothing, mu into normal plus mg sin theta. As per the mu, 10 lambda, and normal force equal to your mg cos theta plus mg sin theta. Now simplify. Mg we can take common from 10 lambda, sin lambda by cos lambda. So this term will be your sin lambda cos theta plus cos lambda sin theta by cos lambda. After further simplifying, so you will get mg sin lambda plus theta by cos lambda. So this is the F external which is needed to move the block with a uniform velocity. As per the given option, our correct option is your option number 4, which is your mg sin theta plus lambda by cos lambda. So finally our answer is your answer number 4. Now come to the next question, question number 28. Now question number 28, the question is like this: a block of mass m1 is placed on another block of mass m2. which itself lying on the horizontal surface, and the coefficient of friction between the two blocks is mu1, and the between the block and the horizontal surface is mu2. The maximum horizontal force that can be applied to the lower block so that the two blocks just tends to move together without separation. So, first option is given m1 minus m2 into mu1 minus mu2 into g. Second option given m2 minus m1 into mu2 plus mu1 into g. Third option given m1 plus m2 into mu1 minus mu2 into g, and the option 4 is given m1 plus m2 into mu1 plus mu2 into g. Now see how to solve this problem. See, first of all, understand the problem. Question is like this, this is your horizontal surface, one block is your m2, over another block m1 has been kept, and there is a friction between the blocks as well as between the block and ground. So, where mu1 is given between the blocks, mu1 friction coefficient between the block, and mu2 is your between the ground and the horizontal surface of the block m2. Now, they are asking what could be the horizontal value of force F, so that, or what is the maximum value of F till both the blocks are moving together. See, there is no slipping between m1 and m2. So, what is the condition for that? See, let A is the acceleration of block m2 like this. We can say in this manner, let m2 is there and this is the block m2, F is this, acceleration of block m2 is this, here one friction will be there F2. Now, one friction will be here F1. See, now I am making FVD of block M1 with respect to block M2. Because we want to see the slipping between the M1 and M2, it will be better to make FVD of block M1 with respect to M2. See, the first thing is that as the block M2 is moving rightward with acceleration A, the first thing is pseudo force, which is your M1 into A. Because of that pseudo force, it has tendency to move in the leftward, so friction will act, and that friction will try to stop the relative motion or try to bring both the block together, but friction have limiting value. So, M1A, as the force here increases, acceleration A is increases, the friction also increases till both are moving together, but there is certain limitation for a friction up to which relative motion between these two start. So, for just to start relative motion, F1A must be equal to your, which is here F1, we can say F1 max, and this is nothing mu1 m1 into g. So, A must be equal to your mu1 g. It means relative motion start when force on M2 block is such that it start accelerating with acceleration mu1 into g. So, F maximum minus F2 max minus F1 max is equal to your mu 2 into A. So now we can use this relation. F2 max, F2 your friction coefficient mu 2, M1 plus M2 is the weight. So M2 plus M1 into G. This is your F2 maximum. F1 maximum, that already we have calculated, minus and then plus mu 1 M1 G and then plus M2 into A. A is your this, the mu 1 M2 G. So this is the finally we are getting the answer. So F maximum must be equal to, now we can simplify mu 1 here, M1 plus M2. So M1 plus M2 into G we can take common. So here in the bracket we will get, this is mu 2 plus 2 mu 1 into G. So this is the maximum value of friction. So once again we can check it. So for maximum value of friction, this we have to move. So since A has to move, there's a maximum value of F. They are asking what is the maximum value of friction force, so that there is a relative motion between the two blocks just start. So two block will start relative motion. So when the acceleration of the lower block is your mu 1 into G, for that condition we can apply F minus mu 2 max minus F1 max is equal to your mu 2 into A, and F2 maximum is equal to mu 2 M1 plus M2 into G. F1 maximum is equal to your mu 1 M1 into G and mu 2 M2 into mu 1 G, and after simplifying this is the answer. So according to the options, our correct option is your 4, which is this. Okay, now see the question number 29. The question is like this: a body is placed at the middle of a plank of length L, and the coefficient of the friction between the body and the plank is mu. If the body moves with an acceleration A, the time after which the body leave the plank is. Now, according to the question, it is given as, let this is a plank, and this plank kept on a ground, and the length of the plank is given L. But at the middle, a body has been given an acceleration A. So how much time it will take to come back or to come down from the plank? So there is no issue at all. Friction coefficient given here mu, and as soon as the body start moving in that direction, so friction force will act in this direction. Because of the friction, there is some retardation which is equal to your mu into G. So net acceleration. So net acceleration on the body is your, so A net, that is your A minus mu G. This is the net acceleration, and because of this net acceleration, now the body will travel and it has to cover the distance here L by 2. So as per the relation, S is equal to ut plus half at square. S is here L by 2, ut 0, half. A is the net acceleration, which is your A minus mu G into t square. So t is the time, that is equal to your L by A minus mu G. This is the answer, and as per the answer, our key number or our option, your third is the correct option. So answer third, the correct key. Now come to the Next problem, question number 30. Now question number 30, the question is given as a smooth inclined plane is making an angle 30 degree to the horizontal and a rough inclined plane of the same length is held at an angle 45 degree. A body is released from the top of each inclined plane, reaches the bottom after the same time. So we have to find the coefficient of friction for that body and the rough plane. Our first option is your root 2 minus 1 by root 2 plus 1. Second option is root 2 minus 1 by root 2. Third option is root 2 by root 2 plus 1. And the fourth option is root 2 plus 1. Now see how to do this problem. Here there are two inclined plane is given. One is making angle 30 degree with the horizontal. Another is making an angle 45 degree with the horizontal. Both plane have same length, but the only difference is that the plane which is making an angle 30 degree, that is your smooth, while the plane which is making an angle your 45 degree, that is the rough. But both are taking the same time to coming from here to the ground. So in this case your body will come with the acceleration g sin 30, and here g sin 45 in this direction, but because of the friction mu g cos 45 in the opposite direction. So net acceleration A net we can say g sin 45 minus mu g cos 45, or we can say g by root 2 1 minus mu. This is the net acceleration and both are traveling same distance. So here L is equal to half g sin 30 into t square. Similarly for that, L is your half and g by root 2 1 minus mu to t square, and both are the same, so both we can equate. So we will get 1 by 2 g sin 30 is equal to your g by 2 root 2 1 minus mu. So g by 2 and g by 2 cancel, 1 by 2 1 by root 2. So it will be finally 1 by root 2 is your 1 minus mu. So mu is equal to 1 minus 1 by root 2. So this is the root 2 minus 1 by root 2. And now see according to our option number second, it matches with the given answer. So we can say answer number 2 or option number 2 is the correct option. Now see question number 31. The question is given as a body is projected up along an inclined plane of an angle with velocity v1. If it reaches the bottom with velocity v2, then we have to find v1 by v2. Take mu as the coefficient of friction of the body. The first option given as sin theta plus mu cos theta by sin theta minus mu cos theta to the power 1 by 2. Second option is given as sin theta plus mu cos theta by cos theta plus mu sin theta to the power 1 by 2. And the third option is given as sin theta minus mu cos theta by cos theta plus mu sin theta to the power 1 by 2. And the fourth option given as cos theta plus mu sin theta by cos theta minus mu sin theta to the power 1 by 2. Now see the how to do this problem. So here in this question it is given a body has been projected with velocity v1 and it reaches to inclined plane, then it coming back to the same position. with velocity v2. So we have to find the relation between v1 and v2. Question like this. Inclined plane theta is given, and now this body is projected with velocity v1. It is reaching somewhere here. It is reaching somewhere here. Now it is coming back. Now it is coming back, and when it reaches again to the bottom, then its velocity or v2. So we have to find v1 and v2 value. So one thing we can do, either this problem can be solved in a simple way by using the work energy theorem. So what we can do, first the body is going from here to here. Here velocity of the body is 0. Kinetic energy is 0. Let the length of this your L. So when the body is going up, the friction force acting in the backward direction. First, see, from A to B journey or for A to B, work done by all forces is your change in kinetic energy. So final kinetic energy is 0 here. Initial here half mv square, the final 0, minus half m v1 square, work done by all the forces. So when it is moving in that direction, downward forces are your friction and mg sin theta. So those forces downward, but body is moving upward. So minus mg sin theta into L minus F into L. This is let your first equation. Now when it is coming down, for B to A again, B to A again here, when it is coming down, so here velocity or V2, here velocity 0, the change in kinetic energy half mv2 square minus 0. Here motion in that direction, so minus is not taken here because mg sin theta and direction of motion same, but right now friction in the again in the same direction here, so minus F into L. This is your second equation, and now these two we can simplify. So do this one. So from here we can either divide these two. Now if we are dividing, v1 square by v2 square, this minus minus all can be taken as 2 plus is equal to mg sin theta plus F into L by mg sin theta minus F, and F is here kinetic friction, which is equal to your mg, F is mu mg cos theta by mg sin theta minus mu mg cos theta. So finally we can say v1 by v2 is equal to your mg and mg cancel. So root over sin theta plus mu cos theta by sin theta minus mu cos theta. This is the value of v1 by v2. So as per the given option, sin theta plus mu cos theta by sin theta minus mu cos theta, our option number 1 is correct. So finally answer your answer number 1 is the correct option. And now come to the next problem, problem number 32. Now see question number 32. The question number 32, it is given a small block slides without friction down an inclined plane starting from rest. Let Sn be the distance traveled from time t is equal to n minus 1 to t is equal to n. Then Sn by Sn plus 1 we have to calculate. So it is given as, and there are 4 options are given here. One is first option 2n minus 1 by 2n. Second option is 2n plus 1 by 2n minus 1. And third option given 2n minus 1, 2n plus 1. And the fourth option is given as 2n by 2n plus 1. Now see how to do this problem. In the question they are saying a particle is kept on a inclined plane starting from rest. See, let the inclination of the plane is theta, and when we are talking about the particle start from rest u0. So what are the acceleration? One your downward force, your mg sin theta, another your friction. So the net acceleration we can say a net is your g sin theta minus mu g cos theta. This is actually net acceleration. So we have to find distance traveled by the particle in nth second. Nth second means in the tn second. That distance we will let Sn, and then Sn plus 1 in a t n plus 1th second. So what we will do, the Sn second means distance traveled by the particle here. See, Sn is equal to, this is actually tn that. Sn is equal to your Sn minus Sn minus 1. And Sn plus 1 means here Sn plus 1 minus Sn. So these are the main point which we have to calculate. See, Sn here, half, same method, as we know S is equal to ut plus half at square. Same thing we are using here. Sn ut is 0, half, a value g common, sin theta minus mu cos theta, t square means nth means n square, then n minus 1, minus of n minus 1 square. So this is the meaning of Sn. Similarly, Sn plus 1, half g sin theta minus mu cos theta, then n plus 1 square minus n square. Now see the ratio of this. Sn by Sn plus 1, this is equal to your n square minus n minus 1 square by n plus 1 square minus n square, and simplify. A square minus b square means a minus b. A minus b means n minus of n, just a minus b plus a plus b. A plus b means here 2n minus 1 by a minus b your 1, a plus b your 2n plus 1. So finally we can say Sn by Sn plus 1 is your 2n minus 1 by 2n plus 1. So as per our options, so option number 3rd is the correct answer. So answer is your 3rd option is the correct option. So this is the question number 32.